So we're talking about velocity. So remember, velocity is the derivative of position function. And what's the derivative of velocity? Acceleration. So particle moves along the y-axis. So think all this particle does all its life is just go up and down the y-axis. So much fun. Okay. Its velocity is given this time. Velocity is the derivative of the position function. So you got to watch out for the phrasing here. Find the time at which the particle reaches its highest point. So it's maximum position. Does that make sense? So highest point means I want to find the maximum position. So here's where we're starting to bring in kind of more of those, and we're going to spend a whole day just on like real world application with this stuff. Whatever you want to maximize or minimize, you must first have an equation for that. Then to maximize or minimize, you take its derivative. Do we already have the derivative of its of position? Yes, that's already given it to us as velocity. So do I need to take the derivative of the function that's given to me? No. That's if I wanted to maximize what? Velocity. If I wanted to find where is its maximum velocity, you would take the derivative of that. So pay attention to your phrasing. Now, what else is an interesting phrase here? It says, what is its highest point, the maximum position? What does that imply? There's only one, it's an absolute or a global. So if I say the highest, that means an absolute. Now, the first derivative test, what did I say? It only finds what type of maximum? Relative. There's one little caveat that comes with that, okay? Think about a parabola. A parabola only has one and only one vertex, right? Either at the bottom or at the top. Because a parabola only has one turning point. Let me say it again. A parabola only has one turning point, one critical point. If a function has only one critical point on its domain, and at that critical point you have a relative max or min, guess what? It's also a absolute max or min. Okay? I'm going to write that down. So if a function has a single critical point on given domain. That's important because what's our given domain in this problem? Greater than or equal to 0. So on greater than or equal to 0, if you have one critical point on the given domain, and it is a relative extrema, because it's not guaranteed that it's a relative extrema. If you find that it is a relative extrema, then it is an absolute extrema. Sorry, my handwriting is getting a little sloppy. Let me know if you can't read any of that. So if you have one single critical point and it is a relative max, then it is an absolute max, or vice versa. Not vice versa, or a minimum. Okay, so let's try this now. So let's remember, do we have to find the derivative of velocity in this problem? No, because I'm trying to maximize position. So what are we going to do with that velocity function then? Set it equal to 0. Let's also think about where this is undefined. Part of me throwing all these different functions at you is I want you to start thinking about when are things undefined. That inside function, e to the t, is e to the t ever undefined? No. Let's think about inverse tangent. I introduced that to you again last class. Remember, inverse tangent looks like this graph right here. That's a really popular one in calculus. Is that ever undefined? No. Is there a y value for every x value? Yes. Horizontal asymptotes are okay. Vertical asymptotes are not okay. So is there any restriction on this? That means, is there any place where this expression would be undefined? No. But you want to always think about it. So now we are just solving this for 0. It looks at first glance like we need a calculator, but we actually don't. First step I would do is move, the 1. So really I'm looking for when is the inverse tangent equal to 1, correct? Inverse tangent. Remember, when you're solving an inverse trig function, you're looking for an angle measure. At what angle measure, ignore the e to the t, at what angle measure is tangent equal to 1? A 45-degree, or in radians, pi over 4. Remember, there's multiple times that happens, but remember, inverse tangent is restricted. Remember that? So it's only pi over 4. Everybody agree? So what you now get is that e to the t is equal to pi over 4, and therefore t is equal to a lovely expression, natural log of pi over 4. How many critical points does this function have on its domain? 1. So now when I do the number line analysis, now let me show you how to do a number line analysis when I'm restricted on my domain. Here's what I like to do. So I like to say, okay, I can equal 0, so I like to put a bracket of 0 and show that I'm only looking from 0 on to infinity. And then at my critical point, I'm going to have natural log of pi over 4. So whenever you're restricted, I kind of like to put brackets or parentheses on either end to show I don't care what's happening to the left of 0. So I have a single critical point. Now, if we can show that that changes sign, or specifically from positive to negative, then we know it is not just a high point, it is the highest point. So let's do that really quickly. Don't just take it for granted, because sometimes the AP test will throw you a curveball and it's now a minimum. And you're like, oh, just kidding. It's not a max because it changes. You know what I'm saying? So you do need to test. This one's a little bit harder, but you see my original function is 1 minus inverse tangent. Well, for values less than natural log of pi over 4, so think of inverse tangent, right? Okay, here's the point that I'm talking about. This is occurring at 1. So for any value up until that point, you see how that's less than 1? Okay, so if you're taking 1 minus a value that's less than 1. So anything in here is going to be positive. Past that point, you're taking 1 minus a value that's greater than 1. Does that make sense? So then it will, in fact, be negative. Okay, so to justify this answer, so just looking at the number line, I can say, well, that's a relative max, but how do you justify fully? It's basically what I just wrote in red. Here's how you fully justify. V of t changes positive to negative at t equals natural log of pi over 4. And since this is the only critical point, I'm going to say on the domain, for t greater than or equal to 0, then therefore it must be the absolute. And in the way I'm going to rephrase it the way the question phrases it, the particle reaches its highest point at t equals natural log of pi over 4. So a little bit more there that you have to write, but you have to fully justify. So since it's an absolute, you have to state that it's the only critical value, and you have to state that it's changing from positive to negative.